Hi, my name is Ken Bingham. I'm with ACM Facility Safety, and one of the features that I'd like to talk about is this quad model, and a specific feature in this quad model is about getting some benefit from using this quad model. Now, the primary benefit is basically making sure that you're actually performing the required functions in each quadrant, but there's some financial benefit here. For instance, in the first quadrant, when you're actually assessing whether you have enough safeguards in place or not, you may find that you've got too many safeguards. So you have an opportunity to actually reduce the safeguards in your plant. And remember, these safeguards that you put in here, you identify here that you need, are going to be maintained for 25 to 50 years in your plant. So, taking and removing stuff in the first quadrant when you're assessing your risk and assessing whether you actually have too many safeguards is a very critical benefit, and it's also a real payback for following the SIL standards. So in quadrant 2, you're going to actually be modeling and performing SIL verification and actually building up this safeguard. What does this look like? How many components do we need? And in this case here, you have the opportunity to, again, reduce the number of components you have by perhaps increasing the testing frequency of the models that you create. Or going the other way, you can actually extend the testing frequency. In other words, instead of 2 years or 3 years, you can extend it to maybe 5 years and put in a little more hardware so you can actually survive a failure. So that's fantastic. Now you're adding in more capital costs, but you're reducing the operational cost. So the Q2 is a real balance between CapEx and OpEx cost. You basically need corporate management to decide where they want to save some money. Often, if you let the project manager that's in charge of the project, he obviously will save CapEx cost, but if you have operations people involved and they have a say, they want to save OpEx cost. Quadrant 3, again, it's basically for every component you design in the first 2 quadrants, or you say is required, those components will actually be bought and built and programmed and engineered and installed in quadrant 3. So it's sort of a multiple. So any component you can save from that design and build and wiring and infrastructure cost, is an increased savings, and that's why you sort of see the little bar graphs actually increasing from quadrant 1 to quadrant 2, and then it's even larger in quadrant 3. And then you have the quadrant 4, which is the operations and maintenance quadrant. And the opportunity for cost savings there is obviously if you have less components to maintain, fantastic. But the other side of it is that if you have natural trips, so you actually, in the case of if you have a high level on an inlet separator and you actually your plant trips successfully, well, you can take credit for that, so that you can actually delay testing your system for another 36 months or another 60 months. So in actual fact, you're actually monitoring the functions that are actually occurring, and you can actually take credit for that in the 4th quadrant. And again, the standards will allow you to do that because you've actually proven that the functionality is still intact.